This is a limit of a function. Under limit, I've started in my last videos. I've explained limits by direct substitutions. I've explained limits by factorizations, and a little bit under limit by standard results. So I want to complete the limit by standard results, and after that we explain the L'Hopital rules. Now, when I say limit by standard results, let us look at these three questions on the board. Number one says that lim sine 8x all over 3x and x tends to 0. So when we are having something like this, how do you do it? It's a limit. Do not forget that under limit, sine x all over x will give us 1. So we are going to follow this. So that is going to give us 1. Now let's see what I'm going to do here. That will be sine 8x. I want to make sure that something 8 come under this. I can say 1 all over 8 times 8 multiplied by 3x. See what I did? Because 8 times 1 is 8. And 8 all over 8 is 1. So everything here becomes 1. As if I don't write anything. As if I write this thing. I just focus, I target this number to create a fractions that will end up as 1 here. So what will I do? I can now do like this. I can bring this 8 here and bring the 3 to come here. That means sine 8x all over 1 all over 8 times, like I bring the 3 here, 3 times, if 8 come here, become 8x. Become 8x. That means we are going to have, now look at this, everything you see here, it turns to 1. It turns to 1 according to this, because this 8x all over 8x, when you have the same thing here, and that is 1. So if all of these things comes to 1, that means 1 all over, we are having 1 all over 8 times 3. Times 3. So if you are having 1 over 8 times 3, that means we have 1 all 3 times 1, that is 3 over 8. So if you apply your fractions, when you have something like this, just do, that is 1 divided by 3 over 8. That is 1 over 1. This division comes to multiplication times, and this one will now go up, this one will come down. 8 over 3. So we are having 8 over 3. The answer is 8 all over 3. So that is number 1. That's number 1. Now let's take a look at this number 2 under the standard result. We are having lim sine 2x all over 5x. Under the standard result, x tends to 0. So I will do the same thing. Sine 2x all over, I will target this number to create a fraction that will end up as 1. That's 1 all over 2 times 2. 1 over 2 times 2 multiplied by the 5x. What will I do? I will just exchange the positions. I will bring 2 here, I'll bring 5 here. So I'm going to have that is sine 2x all over 1 all over 2 times. Once I brought the 5 here, 5 will become a 5 times 2x. So I'm going to have sine 2x all over, that is 5 times 1, that is 5. 5 all over 2 is 5 all over 2 times 2x. So this one turns to 1 automatically. That is 1 all over, so I have 5 over 2 here. So if you do the same thing we did the other times, so this one ends up as 2 all over 5. That's number 2. That's number 2. Now let's do this number 3. 7x all over sine 3x. X tends to 0. So you can just, for this case, you can just say multiply by 7 all over 7. We are targeting this. Multiply by 3 all over 3. Multiply by x all over x. I use this, and I use this. So, what am I trying to do? I can now bring this 7 here. And I'll bring 3 to come and change position here. So that will give me sine 7x all over. Once I brought this 7 here, it becomes sine 7x also. So that means multiply by 7 all over. No, 3 has come here. 3 times 3 all over 3 times x all over x. Automatically, this one has turned to 1. 1. So that means this one has turned to 1 and 1. So our answer is 7 all over 3. So that is for the standard result. Now let's talk about the L'Hopital rules. When are we going to use L'Hopital rules? There are times we apply L'Hopital rules to make things easier. Now, these are the criteria to use L'Hopital rules when we are having 0 all over 0 as a result. Anytime either you are given questions under limit of a functions, and either you see it as a direct substitution, and what did you get? You now later getting 0 over 0 as the answer. That one is called indeterminate. That is not, you cannot just stop there and say that's your answer. Or you get infinity all over infinity. It is indeterminate. If you get any result, if you get answer that stands like all these things, so that is, you can apply L'Hopital rules to get the real answers. If you get something like this, 0 over 0, infinity over infinity, 0 multiplied by infinity, 0 raised to power 0, infinity raised to power 0, 1 raised to power infinity, and infinity minus multiplied by minus infinity. All of this you can now apply. These are the criteria for applying L'Hopital rules. Now, let's say you have a question like this. If you put direct substitution, let's say you look at the direct substitution, anywhere you see x, you are putting 0. Now, let's see, that will be 2 times 0 minus 0 cos 0 all over 0 plus sine 0. Now, tan 0 is 0. Tan 0 is 0. That means 2 into bracket minus cos 0 is 1. Multiply by 1, 0 plus sine 0 is 0. That means 2 times 0, that is 0. Minus 0 times 1, that is 0. All over 0 plus 0, that is 0. 0 minus 0, that is 0 all over 0. So this one is called indeterminate. Indeterminate. That means it cannot be determined. Compared, that if you look at it, that is 0 over 0. So we call it indeterminate. That means this is not the right answer. You cannot apply direct substitution for this. And in this case, we can now use L'Hopital rules. Now let me show us how to use this rule. When I say L'Hopital rule, that means we are going to differentiate it. We're going to use our knowledge of differentiations here. Now let me differentiate it. So what is differentiation of tan x? That is sec square x minus differentiation of x cos x. Let me show you. If you are given x cos x, you can apply our product rule, uv. You remember v du dx plus u dv dx. If I say v du dx plus u dv dx, these are v cos x. You will differentiate this one, which is u 1 plus u. What are u? X. You will differentiate this one with v cos x. Cos x is minus sin x. So that means 1 times cos x plus times minus x sin x. That means x cos x will give me cos x. Let me put it inside the bracket because of this minus. The differentiation of x cos x actually give me this. Give me cos x minus x sin x according to the product rule. Now, all over. What's the differentiation of x? That is 1. Plus differentiation of sin x is cos x. Can we see? we have differentiated everything here. And x tends to 0. Don't forget. Let me substitute x for 0 now. That means 2 sec square 0. Now minus cos x. That's minus cos 0. Minus and minus plus. Plus 0 sine 0 all over 1 plus cos 0. Now I've substituted everything. Now what are we going to have? That means sec square 0. Sec comes from, that's inverse of cos, 1 over cos. That tells you that cos 0 is 1. For the fact that sec is also 1 all over cos. So that means sec 0 is also 1. So that means if sec 0 is 1, 1 square is still 1. And 1 times 2, that is 2. Minus cos 0 is 1. Cos 0 is 1. Plus sine 0 is 0. And 0 times 0 is 0. So that one has gone. All over 1 plus cos 0 is 1. That is 2 minus 1. That is 1 all over 1 plus 1. That is 2. So that is our answer is 1 over 2. That is the reason we use L'Hopital rules. Now let's take another example. When to use L'Hopital example, L'Hopital rules again. They give us number 2. They give us lim cosec x minus cot x. X tends to 0. Now, if you are having something like this, you say lim cosec x minus cot x, x tends to 0. Now, if I say direct substitution, if I'm putting 0 here, let's say cosec 0 minus cot 0. Now, cosec is an inverse of sine, and sine 0 is always 0. That means cosec 0 also will be 0 minus, and the cot 0, cot is an inverse of, that is sine over x, but cot 0 is an infinity. It is infinity. As cot 0 is an infinity. Can we see? We have something like this, and anytime you have something like this, you cannot, in fact, cosec 0, sine is 1 over 0 is infinity. 1 over 0 is infinity. Do not forget that 1 divided by 0, it is infinity. Why is 0 divided by 1? It is 0. Don't forget, because cosec is 1 all over sine. And 1 all over sine 0 is 0. So 1 all over 0, it is infinity. Why is 0 all over 1 is 0? So that means that this guy is also infinity minus infinity. Can you see something like this? It exists here. So that means it is indeterminate. It is indeterminate. Indeterminate. So you cannot stop it. So that means you cannot apply L'Hopital rule. You can apply L'Hopital rule. When I said, so what is cosec? Cosec is inverse of sine. That means 1 all over sine x minus cot x is sine, tan x is sine all over cos. Cot will be cos x all over sine x. That is cot x. What is the LCM? LCM will be sine x. Sine x is sine x. 1. 1 times 1, 1. Minus sine x is again 1. 1 times cos x, cos x. So I cannot differentiate it. If I want to differentiate, what differentiation of 1? I 0 minus, open bracket, cos x is minus sine x. I'm differentiating it. And sine x is cos x. So what does that give me? That will give me minus times minus plus. That is sine 0 all over cos 0. So what is cos 0? Sine 0 is 0, cos 0 is 1. I've told you 0 divided by 1, it is 0.